Hi everyone, in this video made by Chris Evans, Sigurlaug Jonsdottir and Tess Julien, we want to show you our computer science capstone project of spring 2020. For our project, we made a software system that we call Flame. Flame is a web application with the purpose of being an educational tool showing the properties of fire in the environment. The environment is controlled by the user in order to see how the fire will behave in those situations.
The main target user for Flame is students in grades 6 through 9, ages 11 to 14. We are targeting these users because this is the time of their life and schooling where they're starting to learn about the properties of fire, as well as starting to learn about particles that make up the fire, as well as different things in life. While the students are the main target, we wanted to also target the middle school teachers because we wanted to make it so it's appropriate for classroom usage. If we made it too much as like a game, teachers may not want to use it as part of the educational setting. If we make it too educational, then students' attention won't be on it and they'll just see it as another lesson. There are two main use cases that we see Flame being used for. The first one is for a middle school science class. Now there's two different scenarios with this as well, as it could be used by teachers for lecture and demonstration purposes. So they would put it up on the projector screen and would adjust the sliders to talk about the different environmental factors and then students would be able to see how those factors in turn affect the fire particles, as well as a teacher could give it as a homework assignment where students would go and have a worksheet with different adjustments for the sliders on it, and they would be able to move that and then describe what happened to the fire. Another use for it would be a fire safety training for middle schoolers. Flame has an overlay button that when clicked will give instructions for how to put out the fire based on the fuel type that has been selected by the user. So you would put out a wood fire differently than you would put out a grease fire. And this would be explained in the safety overlay, which is why it could be used as a safety factor.
Our application opens to the About page. Here, users can learn about the purpose of our site. By clicking on the items in the menu on the left side of the page, the user reveals information about the factors that influence the simulation. For example, the fuel size is represented by a slider that impacts the simulation by controlling the amount of material that is the source of the fire. Another example is a drop-down menu from which the user can choose to add a chemical to the fire. Each of the items in the slider information menu corresponds to a control in the Simulations tab. The fire simulation page has a series of sliders and menus that represent the physical factors that influence fire. The fuel size, oxygen level, temperature, and dew point temperature sliders affect the size of the fire. If the fuel size or oxygen level is set to 0, the simulation ends because a fire will not exist without fuel or oxygen. Together, the temperature and dew point sliders determine the relative humidity. The dew point temperature can never exceed the physical temperature, so the scale of the dew point temperature slider changes based on the temperature slider. When the dew point temperature equals the air temperature, it starts to rain. The wind speed slider affects the movement of the fire. Adding chemicals to fire can change the color of the flame. Changing the fuel type changes the graphic in the simulation, and it affects the message in the safety overlay. The Reset button sets all of the menus and sliders to their default values. We also included an author's page to provide background to why the application was created.
Flame uses 4 languages. The first language is HTML, which allows for the creation of the web application and houses all of the information that will be displayed. CSS is the design language for Flame. It controls size, color, and location of every aspect that's being displayed. JavaScript is used within the HTML to allow for buttons and tabs to work. When clicked on, it calls a function in JavaScript, which then displays the information associated with the tab or button. Processing is used for the simulation. Here are just a few examples of code that was used to create Flame. On the first left here we have, this is a CSS file that is creating 2 columns for the fire tab to allow for the sliders to be placed next to each other. This one over here is another CSS file for the tabs. This is controlling the color, the size of font, as well as how the tabs are laid out. And this final one down here is HTML for the creation of the tab. This is the About tab in particular, and what you see is it's telling the code where About is located, and then the function that is called when the button is clicked on to then open and display all the information from tab.
There are a total of 5 sliders: wind speed, which simulates a wind going from left to right, moving the particles with it, and has its values ranging from 0 miles per hour to 50 miles per hour. Fuel size, which simulates how much fuel is used to light the fire and therefore how big the fire will be. It has its values ranging from 0 to 10. Those numbers are arbitrary because of the different fuel types we have, but a scale from 0 to 10 is pretty universal in the way that 0 is nothing, 1 is small, and 10 is large. The next one is oxygen level. That slider ranges from 0% to 100% and simulates how much oxygen is exposed to the fire. The temperature slider simulates the air temperature surrounding the fire. Its values range from 0 degrees Fahrenheit to 100 degrees Fahrenheit. The dew point temperature slider simulates the dew point temperature in the surroundings. Dew point temperature measures the temperature at which water molecules condense and turn into water, so it relates to the moisture saturation in the air. The dew point temperature is never higher than the air temperature, and therefore the dew point temperature scale ranges from 0 to the value of the air temperature. The temperature value and the dew point temperature value are used to calculate the relative humidity, which is shown as a value below the sliders. All the sliders show their value above it for the user to see it at all times. In order to make the fire simulation change realistically with the environment controlled by the sliders, we use the Chandler Burning Index. It is an index used to measure fire danger in nature dependent on the temperature and the relative humidity. Therefore, we were able to use that index to change the size of the fire under the assumptions that when the fire danger is low, the environment is not ideal for a fire, and the size of the fire will become smaller. Similarly, if the fire danger is high, the environment is ideal for a fire to burn, and therefore the fire becomes larger. You can see the equation used on the screen, as well as the equation used for the relative humidity. For both equations, the temperatures are measured in degrees Celsius, so the values from the sliders had to be converted before they're used. The Chandler Burning Index ranges from less than 50 to greater than 100, but with our control values, the minimum CPI value was negative 3.4 and the maximum was 233.2. The goal with the calculations was to figure out how many particle systems we wanted to show in the simulation and get a low integer starting at 0. Therefore, we normalized the CPI to get values between negative 2 and 2. To get the number of particle systems, we also had to take into account the fuel size and the oxygen level and came up with the second equation on the screen. This equation gave us values from 0 to 12 and realistically changes the fire as the value on the sliders change. Along with the sliders, there are two drop-down menus that affect the behavior of the fire, the fuel type and the chemicals. The fuel type drop-down has three options: wood, oil, and grease. Like you saw in the demo, the fuel type icon changes with the change of the fuel type, and the safety button will have different messages on how to put out the fire for each one. The chemicals drop-down has four options: no chemicals, lithium chloride, copper chloride, and sodium chloride. The chemicals affect the color of the fire, where lithium chloride turns the flame pink, copper chloride turns the flame blue, and sodium chloride turns the flame orange.
The simulation in our application is run with JavaScript and utilizes p5.js. p5.js is a JavaScript library based on the programming language processing. Processing is intended for visual arts and education, and it uses artistic metaphors such as identifying a program as a sketch. p5.js uses similar metaphors but can be run in a web browser. The fire simulation primarily uses two classes, particle and particle system. The flame element of the simulation is composed of a set of particle system instances. Each particle system contains an array of particles. The movement of the simulation is created by drawing the particle systems, updating the position of each particle in each particle system, and redrawing the particle systems with the new positions. The particle class has four properties: acceleration, velocity, position, and lifespan. The acceleration, velocity, and position properties are vectors, and lifespan is an integer. There are four methods outside of the constructor: run, update, display, and isDead. The run function calls the update and display methods. The update function changes the velocity by adding the acceleration, taking into account the value of the wind speed slider. The position is updated based on the velocity, and the lifespan is decremented. The display function draws the particle. The lifespan affects the color and opacity. The color is also affected by the chemical element drop-down menu. The isDead method returns a Boolean value based on whether the particle has completed its lifespan. The particle system class has two properties, an origin vector and an array of particles. The origin is the position at which all particles in the particle array will be initialized. The addParticle method pushes a new particle onto the array. The run method calls the particle class's run and isDead methods for each particle in the array. If the isDead method returns true, the particle is removed from the array. The overall simulation is run with the draw method. This method finds how many particle systems should be drawn based on the slider values. Then, the function calls the particle system class's addParticle and run methods for each instance of the particle system class. Thank you for watching our presentation. Are there any questions?